So in this video, we are going to cover the elimination method for solving a system of equations. We've done the graphing method and substitution method, and now the final method that we will teach you is the elimination method. So in all the other methods, graphing and substitution, one solution, the answer is an ordered pair. So you're left with an x and a y, and then you put it in the parentheses. Now, infinitely many solutions, the variables wipe out, so we are no longer left with variables. And you get a true statement. So this is going to be very similar to the substitution method. Now with no solution, you will get the variables to wipe out. But in this case, you're going to get a false statement. Now, to the right is the way that I will be showing you in class. There are many different strategies to use for elimination. The goal is to eliminate one variable at a time and then plug it back in or substitute back in your answer to get the second variable. So the most common way is to have it in standard form. So when you have the two equations with the x's and the y's on the same side, as in ax plus by equals a number. But it honestly doesn't matter. So the first thing you need to do is have opposite coefficients. If you don't have opposites in the beginning, then this is a flow map that works every single time. Once again, there's different ways to get opposites. So if you choose to do something different with these two steps and still get opposites, that is fine. So I want you to pause at this moment and read through the flow map. And once you do, you can hit start up again, hit play, and then follow along with example number 1. So example number 1, we have two equations. The first thing we want to do is wrap it up in parentheses because we are going to multiply to change the look of it. So we want to zone in and look at the coefficients of the first variable, in this case x. The first step in the flow map said to multiply the first equation by the opposite first coefficient of the second equation. So in this case, it was a positive 3. So I'm going to make it negative 3. Second step in the flow map, when you paused it, all you're doing is rewriting the first coefficient and you're not changing it. You only change 1. Now, once again, there's many different ways of doing it, but this way always works. We can look right away. If you multiply negative 3 times negative 1, x, you're going to get 3x. If you multiply negative 1 times 3x, you're going to get negative 3x. These two are opposites. We have 3x, take away negative 7, or negative 3x. So that's how we know we did it right. Now continue distributing. Multiply and get negative 15y all the way over the equal sign. We're going to get negative 24. Now continue distributing. Now in the third step, we are making a big adding. The reason why we're adding is because we're eliminating. Negative and a positive go away. We have negative 15y plus 2y. I'm sorry, that should be a 7. Negative 7 is negative 22y. And then negative 24 plus 2 gets us negative 22. Now at this step, we should have a one step, and we should have y equals 1. Now we get to pick our equation. I'm just going to pick number 1. You can pick number 2 if you want. We have negative 1x plus 5y equals 8. All we're doing now is plugging that 1 into the y value. Remember, when we plug something in, we want to use parentheses. And that means to multiply. At this point, we're going to have a two-step. Once we have that, it's very important to have the x comma y. So negative 3 comma 1. So this would be one solution. Now we are going to do the same thing for number 2. We look at the first numbers. We have a 3 and a 2. You decide to make opposite one of them. So I'm going to make 2 into negative 2, and then I'm going to keep the 3. Let's see if that switching works. Yes. When I multiply the first numbers with those outside numbers, I'm going to get opposites. Now all I'm doing now is distributing the rest of the equation. If you did not get opposite x's and you're doing it my method, please take a step back and see where your error was. You need these to cross out for elimination to work. Now we're creating a big adding problem. Negative 6 plus 6x, negative 6x plus 6x goes away, so we don't need to rewrite it. Negative 4 plus 18 gets you 14y. Don't forget the y. And then negative 18 plus 18 becomes 0. Now that's okay because we still have a y value. It's still a one step. In this case, the one step leads us to an answer of 0. 0 is a number, and we're allowed to plug it back in. I'm going to choose the first equation. And then I'm going to replace wherever I see a y with a 0. Two times 0 goes away. We're left with 3x equals 9. Divide by 3, x equals 3. So our ordered pair is 3 comma 0. Now in example 3 and number 4, you're going to notice that we're going to do this first 3 steps together, and then the x's and y's cancel out. So we're going to be left with a infinitely many or no solution. So look here. You want to make one of them opposite. This is a positive 6, so I'm going to make this negative 6. And then I'm going to multiply that by the same. Distribute all the way. We have negative 18x plus 6y equals negative 30. Multiply this way. Positive 18x. Notice right here, we have opposites. That's exactly what we're looking for. And then this is negative 6y, and this is going to get us 60. When we add things together, the x's go away, but notice what happens here. 6y plus negative 6y goes away. When you're left with nothing, you can write a big 0. Negative 30 plus 60 gets you 30. This is a false statement, which leads to the conclusion that there is no solution for this system of equations. Now for number 4, you're going to do the same thing. Make 4 opposite, keep negative 2 the same. So then we're going to have 8x minus 40y equals negative 16. Biggest mistake I've seen through the years, students forget this 4. Be careful, you want to distribute it to every single term. So then we have negative 8x, positive 40y equals positive 16. Now this becomes a big adding problem. 8x plus negative 8x goes away. Negative 40y plus 40y goes away. They eliminate. But notice what happens here. Negative 16 plus 16 also goes away. This represents a true statement. True statement leads us to the conclusion that the answer is infinitely many solutions.